So in this third lesson of homework packet 3.2, we're going to transition from solving polynomials to solving rational equations. So reminding ourselves of what a rational equation is, it's an equation involving the ratio of two polynomials on one or both sides of the equation. So I've got three examples here of rational equations. Notice it says it's the ratio of two polynomials. So in this first equation, I have the ratio of two polynomials. In other words, I have a fraction. It's a more involved fraction because there's variables involved and pluses and minuses of terms in the top and bottom. But this is one rational term right here equals something else. And again, it said it is okay for it to only be on one side of the equation. Number two here, though, shows it's on both sides of the equation. I have one rational term here because the entire top and the entire bottom are separated by that division. And then I have one entire rational term over here because the entire top and the entire bottom are connected through division. This last one again is irrational, but what I want you to notice is this. On one side of the equal sign I have a single rational term, 4x squared over x. But on the other side of the equation I don't have just one rational term here. I have two rational terms. Notice that there's a break in the ratio, and then it says plus another ratio finally equals the 4x squared over 7. Now that's important to note because in this video we're going to be looking at a technique that only works if you only have one rational term on each side of the equation. So the method that we're going to learn today won't work on this one down here. It won't work down here. However, it will work on these two here and here. But it's a no-go on this one down here. You'll see what I mean by that as we look at the next slide. So here's our first example, fairly simple. We're going to solve this rational equation through what's called something that you already know about, cross multiplication. So what are the conditions for cross multiplication? Cross multiplication, the conditions are only one rational term on each side of the equation. So taking a look at our first example here, I have one rational term on the left side and one rational term on the right side. So I can use this method of cross multiplication. Now, cross multiplication can only be done across an equal sign. It can only be done across an equal sign. Don't forget that. If it was 4 over 5 plus 7 over x, you could not cross multiply. It has to be an equal sign between the two for cross multiplication to produce something meaningful. So what is it? As we remember from previous math classes, we're pairing up top and bottom from opposite sides, from across the equal sign. So cross multiplication, we're going to do 5 times 7, which is 35, and we're going to do 4 times x, which equals 4x. So this cross multiply of 5 times 7 equals 35 is equal to the other cross multiply of 4 times x. What I now have is a really simple equation with no more denominators. To finish solving this, all I have to do is divide by 4, and I get that x is equal to 35/4, keeping the answer as an exact solution. No decimal approximations. So let's look at another example here, a little bit bigger of a problem, but still pretty manageable. First, check my condition. Do I have just one rational term on each side? Yep, because everything over here on the numerator is being divided by everything over here. There's no plus another rational expression. Same on the right-hand side over here with the 2x minus 7 all over 5. So we can cross multiply. Now careful, because when you cross multiply, if you have more than one term that you're cross multiplying with, this 4 right here gets multiplied by the 2x, which is 8x. The 4 also multiplies the negative 7, which is negative 28. So it's 8x minus 28. And now I have to do the other cross here. Same thing, this 5 goes to the x, so that it's a 5x, and this 5 goes to the negative 3, so that it's a minus 15. Great, so through the cross multiplication process, I got rid of all denominators, which is what I wanted. And now I've got a simple linear equation here to finish solving. I'm going to subtract 5x from both sides. It's going to give me a 3x minus 28 is equal to negative 15. Now I'm going to add 28 to both sides. So 3x is equal to, I believe that's a 13. And last but not least, divide by 3. X is equal to 13 thirds. And there's the solution to that rational equation. We've got one more example we want to take a look at here. We've got x plus 3 over 4 equals x squared over 3. Again, checking that condition, I have one rational term here and one rational term here. I'm good to go. So, cross multiplication, 4 times x squared is 4x squared. And then 3 times x plus 3, so it's 4x squared equals 3 times the x is 3x. 3 times 3 is 9. So I end up with 4x squared is equal to 3x plus 9. Now, you'll notice that it's not a simple linear equation anymore. We know it's not a linear equation because there's the presence of an x squared term. Whenever there's an x squared, we know it's a quadratic. Okay, but there's no denominators left, so we can deal with that. To solve a quadratic, I always want to set it equal to 0, so I'm going to subtract 3x and subtract 9 from both sides. That gives me a 4x squared minus 3x minus 9 equals 0. Now, I could try factoring this, but I probably would fail because the value in front of here is not a 1, it's a 4 in this case, and then the numbers here are a little awkward. So I'm just going to go ahead and solve this remaining quadratic using the quadratic formula. X equals negative b plus and minus the square root of b squared minus 4ac all over 2a. Okay. Now remember, I can only use the quadratic formula if my equation is set equal to 0, and it is. So this becomes x is equal to negative b is negative 3. Here's a is 4, b is negative 3, c is negative 9. So negative 3 is positive 3, plus and minus the square root of b squared. Negative 3 squared is 9, minus 4 times a, which is 4, times c, which is 9, or negative 9. Negative 9 right here. All of that's divided by 2 times a being the 4. So that's x is equal to 3 plus and minus the square root of, we got to do 9 minus 4 times negative 9. And I'm getting 153. Getting a 153. With 9 minus 4 times negative 9. And all of that is divided by 8. Now the question is, can 153 be split up at all? So that we can simplify it more. 153. 153 is actually divisible by 3. It can be split up into 51 and 3. Now that's not useful yet because I don't have any pairs, but interestingly enough, 51 is often mistaken as a prime number when in fact it can be split up into 7 times 3. 51 is 17 times 3. So we find out that we actually do have a pair of 3's. So this becomes x equals 3 plus and minus 3 comes out, 17 is left under the square root, all over 8. So there are my two solutions, 3 plus 3 root 17 over 8 and 3 minus 3 root 17 over 8. Those are the two solutions to that rational equation.